And so pretty much up to this section, when we've determined probabilities, there aren't a ton of options. I have three possibilities for where I land on the spinner, like three categories, technically 5 different sections I could land in though. So I only really have 3 events that I have to consider to calculate a probability. Same thing like back up here, 3 possibilities. If I start kind of mixing stuff together, then it gets really complicated to keep track of everything, and I might not be able to in my head. So that's where these tree diagrams can come into play. So basically, maybe I'm going to spin the spinner, and then my next event is I'm going to roll a die. And so I'm combining those. There's a ton of different outcomes for that.
Okay.
So the first thing we're going to talk about is the counting principle. Basically tells us how to combine events. Okay. So if an experiment can be performed and I'm going to use different letters than what your book does because I'm terrible at enunciating these two.
Okay.
If it can be performed in C, distinct ways. That's not how you spell distinct. Let's see, that looks right. And a second experiment can be performed in D, distinct ways. Then the 2 experiments can be performed in C times D, distinct ways. So your book uses M and N, and those sound exactly the same out of my mouth, so I don't like using them. So basically the idea is maybe I roll a die that's got 6 outcomes, and then I roll a second die that has 6 outcomes. If I decide I'm going to roll 2 die, in total I have 36 possible combinations because I could get a 1 and a 5, I could get a 1 and a 4, a 1 and a 3, a 1 and a 2. So I have 36 combinations between those two. Okay. That is a lot to keep track of. So that's where these tree diagrams come into play. So tree diagrams are helpful in determining these outcomes. And sample spaces. So ultimately it tells you every possibility in the end. And from that, then I know how to kind of calculate probabilities a little bit better. So the best thing we can really do to determine or to show you what a tree diagram is to draw one. So let's say we flip a coin and then toss a fair 6-sided die. We want to determine the sample space. So that means we basically want to determine every possible outcome from doing these two together. So when we flip the coin, how many outcomes are there?
2.
2. We have 2 outcomes, which are heads or tails. So I'll just use H and T. And then we have a 6-sided die. So that one has 6 outcomes. You can get the numbers 1 through 6. Okay. So I have 2 outcomes in my first event, 6 in my second. How many total outcomes then if I do this experiment?
12.
12. So in total, there are 2 times 6, which equals 12 outcomes. Okay. so I'm going to need a lot of room for this tree diagram. Okay. So the idea is you start here at a point, and it's called a tree because you kind of branch off in either direction. Move this up a little bit. And so we have two possibilities for this first event, which is the coin. For that first event, you have the possibility of getting a heads, and then you have the possibility of getting a tails.
Mhm.
Right? So if I happen to roll a heads, then when I roll the die, I have 6 outcomes that can happen after that. So we branch off again to see what happens for the die. So I could roll a 1, a 2, a 3, a 4, a 5, or a 6. Okay. But then I could do the exact same thing if I roll a tails. I could roll tails and then a 1, 2, 3, 4, 5, or 6.
Mhm.
So I could branch off this way and I have 6 possibilities again. So we're basically connecting all the different events together. And then from that, it's much easier to actually write all of the possible outcomes. I don't have to think in my head and kind of, what's the word I'm looking for? I don't have to keep track of things in my head or try to make sure I'm pairing everything. This has done it all for me.
Mhm.
So basically, I have one event where I can get a heads and roll a 1. So the heads come first, followed by a 1. Or we get the heads and a 2. So the next event in my sample space would be heads and 2. And then you just keep going down the line. You follow all of these branches. You
Mhm.
get a heads and 3, a heads and 4, a heads and 5, a heads and 6, and then we do the same thing with tails. A tails and 1, a tails and 2, a tails and 3, tails and 4, tails and 5, and then squeeze this in, a tails and 6.
Mhm.
And this gives you all 12 outcomes that can happen in that sample space. Okay.
Mhm.
So this tree diagram is going to be really super effective for combining all of these events. Okay,
Okay.
feeling okay with this so far?
Mhm.
Okay.
Is this the end of it, or do we saw
Yep.
something?
That's it. That is our tree diagram.
Oh, okay.
So our next example, this will be the last example I do today. We'll create this tree diagram and then we'll utilize that to actually calculate some probabilities.
Okay.
Okay. All right, so you can see they get really large very quick. All right, so you will purchase one appetizer, one beverage, and one dessert from the list below. And so we've got this long chart. We've got a list of appetizers you can pick from, a list of beverages, and then finally our desserts. So for the appetizers, you can pick mozzarella sticks. And so I'm going to use an M to indicate that. Or you can pick guacamole. And I'm going to use a G to indicate that because I definitely don't want to write these words over and over. For the beverage, you could pick a soda. We use S here, or a lemonade, which will be an L. And then you got 3 possibilities for desserts. You could pick a pie, you could pick a brownie, which will be B, or you could pick a cake. So everything is written by their letters. So we want to first, I'm gonna do a bunch of different parts to this. We want to determine the number of sample points in the sample space. Okay. So I've got 3 events. How many possibilities in that first event?
For the appetizers, 2.
2. How about for beverages
2.
and desserts?
3.
So what do you think we do with these numbers?
Multiply them.
We multiply them. So the number of outcomes is 2 times 2 times 3, which will be 12. So basically you have 12 menus you could create from these possibilities.
Mhm.
All right, a second thing we're going to do now is construct a tree diagram. And determine the sample space. So I know I have 12 events, but if I just tried to list them out on my own, it's very likely I'm going to forget something.
Mhm.
Okay. So what I'm going to do instead is create this tree diagram, and it's going to have 3 kind of branches. We'll have, use a different color here. We'll have the appetizers going off. So you pick that, follow that branch. And then you get to pick a beverage, and then you get to pick a dessert. And then that creates the sample space over here. Okay. So let's see if I can squeeze all this in. So we start right in the middle. And for my appetizers, I have 2 possibilities. So I'm just going to do 2 branches. We can choose mozzarella sticks, or we can choose guacamole. Then once we've made that selection, I move on to the beverages. And again, I have 2 possibilities. So once I pick mozzarella sticks, then I could pick soda or lemonade. But likewise, if I pick guacamole, I can do exactly the same thing, and I can pick soda or lemonade. And then suppose I pick mozzarella sticks, I pick soda. Now I've got to pick my dessert. I have 3 options for each of these. If I pick mozzarella and lemonade, 3 options for my dessert. So from each of these, we have 3 more branches of that pie, brownie, or cake.
Mhm.
And so the same thing really just gets copy and pasted down. Because for every single one, I can pick pie, brownie, or cake.
Mhm.
Okay. And now to get my sample space, I just follow all the branches. So I can pick mozzarella sticks going through this first branch, pick mozzarella sticks, soda, pie. Following at a different path, mozzarella sticks, soda, brownie. And then my last combination with mozzarella and soda is cake. So mozzarella, soda, cake. Now I've run through all of those. We go to mozzarella, to lemonade, and then each of these 3 desserts. So basically the only thing that changes is the lemonade in the middle. Okay. And then honestly, these are identical to each other. So this does not change. I just changed the appetizer out front for guacamole. So we do guacamole to soda to pie,
Mhm.
guac soda brownies, guac soda cake. Then guac lemonade pie, guac lemonade brownies, guac lemonade cake. That is every possible choice I can make now for this menu.
Mhm.
Okay. So now that I've got every single outcome, calculating my probabilities is going to be a little bit easier because I can just utilize that sample space at the end.
Mhm.
So for our final two little pieces, we're going to determine the probability that you first select guacamole for the appetizer. Okay. So how many points are in our sample space?
1, 2, 12,
Hmm. And how many of them do you select guac for?
6.
Okay, so these 6 out of 12 give you guacamole as an appetizer.
Mhm.
So what would your probability be?
6. 6 to like 6 over 12?
Perfect. So 6 to 12 points in the sample space. Have guac as the appetizer. So our probability of selecting guacamole is 6 out of 12, or really you have a 1/2 chance.
Mhm.
So really you have one of 2 appetizers that give you guacamole. All right, let's try one more. Let's determine the probability that you select lemonade and brownies. So how many places do you see both lemonade and brownies?
Um, 1, 2, 3, 6.
So you have to select both of them.
Okay, so 1, 2, 3, 4, 5, 6, 7, 8.
So that would be if you selected one or the other. But because it says select lemonade and brownies, you've got to
So
do,
both of them?
yeah. If it was
Okay.
or, then we'd be looking for at least one of the letters. But since it's saying
So
and,
2.
two, there are 2 places where I select both of them at the same time. So our possible outcomes with lemonade and brownies would be you select mozzarella sticks, lemonade, and brownies, and guac, lemonade, and brownies. So 2 of your
Out of
12
12?
points.
Okay.
Perfect. So what's our probability?
1 over 6.
Perfect. So 2 of 12 points in the sample space. Satisfy this. So the probability of selecting lemonade and brownies is 2 out of 12 or 1 out of 6. So we are told a hat contains 4 marbles. There's 1 orange, 1 pink, 1 blue, and 1 green. Okay. 2 marbles are to be selected without replacement from the hat. So the idea is I'm putting all 4 marbles in a hat. I pick one out. I look at that color. That marble is gone. Okay. Then I only can pick from what's remaining in the hat. First thing we're going to do is determine the number of sample points. In the sample space. Okay. So I don't know if you've caught up on Monday, cool, or Tuesday, cool if you haven't. Think about this first draw. How many possible outcomes do I have when I pick this first marble? We have 4. So the first event has 4 possibilities. But now, because I'm not replacing the marble, when I go to do the second draw, how many choices do I have? 3. So since we're not replacing the marble, there are only 3 left to pick from. In the second event. Okay. So what we learned on Tuesday was if I have 4 possible choices for the first, 3 for the second, if I'm doing both of these, we multiply them. So the number of outcomes is going to be 4 times 3. Or I have 12 possible events that can occur, or combinations of marbles. So you're just going to multiply. If I had 7 options for the first event, 10 options for the second, you multiply them, and in total you have 70. Okay. Oh, Macy, sorry. Macy, off. Relax. Go back to bed. Take your nappy. Okay. If you tried in your head to figure out every possible outcome, that's when it starts to get a little muddled and you're like, oh geez, did I remember this one? Did I forget this one? So the tree diagrams really keep things nice and organized to help us out. So the second thing we're going to do is construct a tree diagram. And we're going to list the sample space. So basically list out every possible event. Okay. I need to zoom out because these things get super large, unfortunately. So the idea is you're going to start and you're going to pick that first marble. So you have your first event occurring. Then we pick the second marble. And then we'll be able to list that sample space. Okay. So it's called a tree because it looks like there's a bunch of branches. Let me use this whole page. So I kind of start off here and I branch off to have that first event. So I'm picking that first marble. We have 4 possibilities. So we have 4 branches coming off. So let's see. We've got our orange marble we can pick from. So I'm just going to put an O and I'll keep everything color coded. Then we have a pink marble as our possibility. Then we've got a blue marble. And then we've got a green marble. Okay. So this represents the first selection I make. Now that I've selected the first marble, you said there's 3 more choices. So after I've selected orange, what are my possibilities for the second marble? Yeah, so I've got pink, blue, and green. Okay. So ultimately, this tells me my sample space or values in it. I could select orange first, followed by pink. So 1 point in my sample space is I select orange, then pink. I select orange, then blue, orange, and then green. Okay. So those are three possibilities for this combination of events. But instead, I could pick pink first. And then again, I've got three marbles that are left in the bag. What marbles could I choose now if I've picked pink? Perfect. So I can select orange, blue, and green. So that gives me three more events where we pick pink first each time, and then orange, blue, and green. And then you just keep doing this. I select blue, so blue is out of the running. I won't make you type these. We could select orange, pink, and green remaining. So the points in my sample space all start with blue, and then we've got orange, pink, and green. And then we've got one last possibility. Green goes first. I can select orange, pink, or blue. So our G comes first. And then we've got orange, pink, blue. Right. And if you count these up, that's 3, 6, 9, all 12 points. So 12 possible combinations. So it just makes life a little bit easier when you start to have a lot of things going on, because now I know every outcome. So if I ask you now about certain probabilities, I can use this list to really help me out instead. Does this make sense so far? Okay. So we're going to utilize this now to calculate two probabilities. We're going to determine the probability of selecting technically this is C, exactly one pink marble. So if we did not have this list, I definitely could not keep track in my head of every possible outcome. Because in total, we have 12 events. How many of these have exactly one pink marble that's selected? So there's 3 here. Those have exactly one pink. Any others? Yeah. So this has one pink. This has exactly one pink. And this one, same thing, exactly one pink. So 6 of the events have exactly one pink marble. Out of a total of 12 events. So our probability of exactly one pink would be what? 50%, perfect. You have a 6 out of 12, which is a 1/2 or 50% chance. Excellent. Go ahead and unhighlight these. I'll put a little star next to the 3 events or 6 events. Let's try one more, and then I'm going to change really one word in this, and we're going to redo the problem. So let's determine the probability of selecting at least one marble that is not pink. So scroll back up. So this one's a little hard. I want out of my 2 for at least one of them to not be pink. What do you think about this? How many events fit that criteria? Has at least one that's not pink. So if I look like at this event, orange and pink, is at least one of them not pink? Yeah, because I've got the orange paired with it. In all of these yeah, it's going to be all of them. So how many events do we have in total? A little more. Sorry, blocking half of it. All of these contain at least a marble that's not pink. Okay, good. So every event satisfies this. So what's your probability? All 12 out of 12. So you have a 100% chance of selecting a marble that's at least not pink. Basically, if it starts to get complicated to have to sift through everything, the opposite of this is both of them would be pink. And that doesn't happen at all because once I've selected pink, it's gone. There's no replacement for pink. So another way you can kind of think of it is since no event selects pink both times, the probability of at least one non-pink is 12 out of 12, or a 100% chance. So when it starts to get a little more complicated, one thing we can kind of remember is the probability of the event happening at least once is equal to 1 minus the probability that the event doesn't happen. So if the event doesn't happen, that means we selected pink both times. That never happens. So this would be 0. Okay. Do you need this formula? Not really, especially if it's something you can list everything out. So just when things can get complicated, we have this as a tool. So we're going to do exactly the same thing now, but I'm going to change one word. And we're going to go through all of these same exact questions again. Okay, so 2 marbles from the prior experiment. Are to be selected with replacement. So I've got those 2 words with, without. For with replacement, I've got all 4 marbles in. Pick one out, look at the color, pop it right back in the bag. It can be selected again. Okay. For our first part, we want to determine the number of sample points in the sample space. Okay. So for the first draw, how many possibilities do we have? Now I picked that marble, I'm replacing it. So how many possibilities do we have for the next? 4 again. So in total, how many possible outcomes 16, perfect. So you've got 4 on the first draw, 4 on the second, for a total of 16. So I'll label each of these. This you pick from 4 marbles. And then the marble gets returned. So we have 4 to pick from again. Perfect. Tree diagram is going to be much bigger now. So I'm going to need a full page for this one. So let me know when you are good for me to scroll up. Good. Okay. So for the second part, we want to construct a tree diagram and list the sample space. So ultimately, we want to see what that first pick is, and then our second pick, and that will tell us the sample space. Okay. So starting all the way over here, I've got my same 4 possibilities for this first pick. I can still pick orange, pink, blue, and green. Okay. Now, if I follow this one, I've picked orange. I look at it, goes right back in. So what are my possible choices now for my second pick? Can select orange again, pink, blue, and green. Perfect. So you have all 4 colors again. So I can select orange, pink, blue, and green. So for our sample space, orange is selected first each time. But now I have the possibility to get orange and orange together, and then orange with every color. Oh, what just happened? There we go. Sorry about that. Okay. And now we just repeat this process. I pick pink, goes back in. I have all of these possibilities again. So for our sample space, pink is selected first each time. And then you do pink and orange, pink and pink, pink and blue, pink and green. And then really this just gets copy and pasted down. Blue with all the options, green with all of the options. So blue is selected first, and then orange, pink, blue, and green. Green is selected first, and then all the colors again. Okay. So my probabilities are definitely going to change because instead of having 12 events, now we have 16 we can possibly choose from. So let's try those 2 questions again. Actually, we'll just do the 1. I think that's fine. Let's determine the probability that at least one marble selected is not pink. So how many times does this fail where I don't select a marble that's not pink? Once. So there is a single event where both of them are pink. Every other time, I'm good. So how many events fit this category? $15. So you have a 15 out of 16 chance that at least one marble is not pink. Using that formula, I'll show you it's the same thing. The probability of at least one non-pink is equal to 1 minus the probability this event doesn't happen, which means they're both pink. That's 1 minus 1 out of 16 times to give you a 15 over 16 chance.